Hi, it's Mrs. Moss here, and for the next week, we are going to be interpreting geological history. In our reference table, pages 8 and 9, you see a timeline of our geological history of New York State. Well, this dates back to the billions of years ago, to the beginning of Earth's formation. It goes past the 500 million year mark, which includes the Cenozoic era, the Mesozoic era, and the Paleozoic era. And it even dates back to the Precambrian era, which goes all the way back to the beginning of the Earth, 4.6 billion years ago. We even can look at another reference table page and compare it to this timeline, and it will correspond with the landscape development and geological features of New York State. And it gives us a time period of when New York State formed. So how are we able to create this geological timescale chart? I mean, we weren't around billions of years ago. The layers of sedimentary rock and the layers of ancient ice in glaciers are like pages of a book. They tell the story of Earth's history, and we only need to learn how to read the clues. The key to the past is the present. So by looking at rocks today, we can tell what happened years ago. So what are we looking for? Well, we look for fossils. Fossils help give us a time period. And it is about fossils, but we're also looking for more. Scientists are searching for clues of the past within ice core samples. And what are they looking for? Well, they're looking for atmospheric gases that get trapped in those core samples. They're looking for volcanic ash, which may indicate a volcanic eruption and give us another frame of reference for a time period. They're looking for evidence of extraterrestrial impacts. Scientists have even been able to map out certain areas along the ocean floor where craters have come and hit the Earth. And that will also give them a time period of when that occurred. What are we looking for? Well, we look at the order of rock layers. And we look for igneous intrusions that have possibly come up from the magma in the mantle and hardened at the surface. We're looking for faults, cracks within the rock. And we're looking for folds or distortions within the rock. Lastly, we look at glacier evidence, striations and scratches in the rock that tell us once this event occurred. We're also looking for evidence of running water and for wind. What are we looking for? Well, we look for evidence of plant remains through the presence of carbon or coal within the rock strata. We start by looking at outcrops or walking the outcrop. And an outcrop is just a section or an area of exposed rock. If we look at this more closely, we can see order of events that have occurred throughout the years and give geologists a time frame of how old that rock is. Over the next few weeks, we're going to be looking at this very closely, and we're going to be thinking about the laws of rock layers, and we're going to be trying to interpret the order of events ourselves. Let's start with the first law, the law of original horizontality. And this law states that rock strata are generally deposited horizontally. Now, we learned about that when we were learning about the formation of sedimentary rocks. Rocks are deposited in a horizontal layer. That means any tilting, folding, faulting, or contact metamorphism of these rocks came after the original deposition occurred. The second law is the law of superposition, and it states that the bottom layers in a sequence of rock strata must have been deposited before the layers above, unless that rock strata has been uplifted or disturbed. So what does that mean? Well, it means that the older rocks are found at the bottom. So if we're going to use our two laws in this picture, we notice the law of horizontality in place. You can see the rock layers in a horizontal formation. We would also note that by looking at this outcrop, we can see that the oldest is at the bottom and the youngest is at the top. So far, it's not too bad, right? Well, knowing that the rock is older than the process that changed it also helps scientists and geologists to determine the time period and the age of the rock. What processes are we talking about? Well, I'm going to leave you hanging with that one. We're going to talk about that in our next video. I hope you have a great day. See you next time.